Yes. Now come to the two more real functions. Yesterday we had discussed some real functions, Okay, today we are going to discuss two more real functions and it's a graph, that is signum function. These these real functions are useful not only for this chapter, they are also useful for second year also. So listen carefully and learn these real functions and their graphs. Okay, the function, f. F is a mapping from R to R. F is a mapping from R to R. Okay, defined by f of x is equal to 1 if x is greater than 0, f of x is equal to 0 if x is equal to 0, f of x is equal to minus 1 if x is less than 0. Okay, in three different ways f of x is defined. For every positive real number, f of x value is 1. For 0, f of x is 0. And for every negative real number, f of x value is minus 1. Is called the signum function. This function is called signum function. The domain of this function signum function is capital letter R. Whatever the values taken by the variable x, they are called domain of the function, and the range means the function values. What are the function values here? Only minus 1, 0, 1. Only these three numbers. Okay, this is the signum function. F is defined like this. If a function is defined like this, then the function is called a signum function, and domain of the signum function is a set of real numbers, and range of the signum function is set minus 1, comma 0, comma 1. If you want to draw the graph of signum function, this is graph of the signum function. Here, suppose this is 1. So, for every positive real number, f of x value is 1. For every negative real number, For every negative real number, f of x value is -1. So the graph of this signum function will be like this. Please remember this graph. You have to learn the graphs of real functions. And the last one is greatest integer function. Greatest integer function. Greatest integer function. This is also called step function. This is also called step function. Greatest integer function or step function. Okay. Now let us discuss the definition of greatest integer function. Okay. The function f, from R to R defined by f of x is equal to step x. This is read as a step x, not closed brackets x. This is read as step x. Please remember this point. How to read this notation. Comma x belongs to R. Assumes values of the greatest integer less than or equal to x. Less than or equal to x. Such a function is called the greatest integer function. Also, this is also called step function. Both denote the same, step function or greatest integer function. To understand this function, for example, step of -2 is -2 only. Step of 1 only. Step of -7 -7. Step of 10. If you choose integers for values of x, if you choose integers, then the function value is the same number itself, the same integer itself. Suppose if you choose other than integers, suppose 2.1, step 2.1. The value of step 2.1 is 2. On the number line, if you mark this number on the number line, nearest left side integer is 2. For this number, if you mark this number on the number line, what is the nearest left side integer? 2. So this is the function value. 2.5, 2 only. 2.001, 1, 7, 2 only. After marking this number, whatever the values you have chosen for x, if you mark this number on the number line, immediately you have to observe the nearest left side number, left side integer. That number is nothing but the function value. Can you tell me what is the value of step 0.5? Yes, very good, my dear Ria. Very good. Step 0.123. Step 0.123. What is the value of step 0.123? Yes, very good, Rexlin. Very good. Percy. Very good, Samuel. 0. What is the value of step minus 2.3? What is the value of step minus 2.3? Tell me. Very good, Ria. Very good. Not minus 2. Not minus 2. Mark this number on the number line. Mark this number on the number line. After marking this number on the number line, what is the left side number? Left side integer. Nearest left side integer. Minus 2 or minus 3? Tell me. Mark this number on the number line. Yes, minus 3, not minus 2. Don't be confused here. Don't be confused here. Minus 2.8. What is the value of step minus 2.8? Minus 3. Very good. Step 2.00. Step minus 2.001. Yes, minus 3. Left side integer, nearest left side integer. After marking this number, the value of x on x-axis, after marking this number on x-axis, then we have to find out the left side nearest integer. That integer is the value of that function. Step minus 9.8. What is the value of step minus 9.8? Yes, very good. Ria, Percy, Samuel, minus 10. Step 5 by 2. Can you tell me what is the value of step 5 by 2? What is the value of step 5 by 2? Yes, very good. First, to convert this fraction, convert this rational number into decimal form, then what will get here? 2.5. Now, after converting the rational number into decimal form, then mark this number on the number line. Then the this number is that is step minus 5 by 2. What is the value of step minus 5 by 2? Yes, very good, my dear Ashley. -3. Understood this function? Modulus greatest integer function or step function. Okay. Understood how to find the values of the function in the greatest integer function or in step function. Now come to the graph of this function. Graph of this function. Graph of this function. If you draw the graph of this function, it looks like steps. That is why this is called step function. Maybe there may be a network issue. Here I connected Wi-Fi. Okay. Here I connected my devices with Wi-Fi. There may be some network issue. Now it is okay, Percy? Okay, ma. It is okay. So if you draw the graph of this function, it looks like steps. So like this, it looks like steps. So if you observe this graph, it looks like steps. That is why this is called step function. This is a graph of greatest integer function or step function because the graph of this function looks like steps. Yes or no? That is why this is also called step function. These are the different real numbers and their graphs. You have to remember these real functions. Okay, my children. Next point, algebra of functions. Algebra of real functions means sum of two functions, difference of two functions, product of two functions, and quotient of two functions. We discussed these points in this algebra of real functions. Okay. Let x let f is a mapping from x to real numbers and g is a mapping from or g is a function from x to be any two real functions where X is a subset of real numbers. Then we define f plus g of f plus g. It is a mapping from, if you observe, domain of this function f is x, domain of the function g also x. Okay, they should have the same domain. If you apply the algebra functions, means sum of two functions or difference of two functions or product of two functions or quotient of two functions, they should be defined on the same domain. Okay, so f plus g is a function from x to r, and we define f plus g of x. F plus g of x is equal to f of x plus g of x. This is sum of these two functions. Similarly, f minus g is a function defined from x to r, and we define f minus g of x. F minus g of x is equal to f of x minus g of x, just like a distributive property, For all x belongs to x. Here also, for all x belongs to x. Similarly, this is the difference of these two functions. Similarly, product of these two functions. F into g of x, f g of x, f of x into g of x for all x belongs to x. And we define quotient of these two functions. F by g of x is equal to f of x by g of x f of x by g of x for all x belongs to x, provided g of x is not equal to 0, and for all x belongs to x. And we define some constant into f of x as k into f of x, for all x belongs to x, and k is any constant. So these five are said to be algebra of functions: addition, subtraction, multiplication, division, and multiplying a function by a constant. Okay, this is about algebra of functions. And the next point, we have to find the domain of the functions. They will ask you domain of the functions and what is the range of the function. To know the domain of the function, they will give the functions in different formats. In that case, we have to find the domain of X. Suppose Suppose a function is defined f of x by g of x, where g of x and h of x are polynomial functions, where g of x and h of x are polynomial functions. Suppose a function is defined like this: numerator a polynomial and the denominator is also a polynomial function. In that case, to find the to find the domain of this function f, we have to solve h of x is not equal to 0. We have to write this in equation and solve this in equation. Then the values of x which is satisfy this inequation, the values of x which is satisfy this inequation is said to be domain of the function. I will tell you by examples also later. So just remember that if f of x is given in the form of f of x by g of x, then to find the domain of this function, if h of x is equal to 0, this is not defined. This is not a real number. Yes or no? Any number by 0, is it a real number? We say that it is not defined. Similarly, we apply the same rule here. If denominator is equal to 0, then this is not a real function. This is not a real function. That is why we solve this inequation. H of x should not be equal to 0. Okay, my dear children. This is the first type of functions to find the domain. Suppose f of x is equal to square root of g of x, where g of x is a polynomial function. F of x is equal to square root of g of x. In this case, if you want to find the domain of f, we have to solve g of x, whatever the function is given under the square root, we write that function greater than or equal to 0. Under the square root, there should be always non-negative real number. If it is a negative number, square root of a negative number is not a real number. That is why g of x should be greater than or equal to 0. We have to solve this inequation. We have to solve this inequation for x. The values of x denotes domain of this function. Okay, my children, remember these forms, different forms of the functions to find domain. Okay, next one. and domain. Suppose f of x is defined like this. F of x is equal to g of x by square root of h of x, where g of x and h of x are polynomial functions. They are polynomial functions in x. If any function is defined like this, and if you want to find domain of this function f, you have to solve h of x greater than 0, not greater than or equal to. In the previous case, we have taken greater than or equal to, 0, because these in the numerator may be 0 also. But here in the denominator, this function is in the denominator. That is why we should not take the value of this function is equal to 0. So it should be a positive real number. You have to solve this inequation for the values of x. The set of values of x which is satisfy this inequation denote the domain of the function f. Okay. Next, f of x is equal to log of g of x. Logarithmic function. They will give logarithmic function. Okay. Here also solve g of x greater than 0. Only for positive real numbers, logarithmic function is defined. Only for positive real numbers, logarithmic function is defined. So, g of x should be greater than 0. Okay, my children. Like this, they will give different types of functions to find domains of the functions. Especially, you have to remember these 4 types: f of x by g of x, f of x by g of x, root g of x, g of x by root h of x, log modulus log g of x. Okay. And modulus function. F of x is equal to modulus of g of x. This function is defined for all real values. Okay. So, domain of f is a set of all real numbers. No need to solve any inequation. This is about finding domain of a given function. Now they will ask sometimes, find the range of the given function. Okay. Next point. Sometimes we have to find a range of a given function. In that case, how to find range of a given function? We follow these steps to find the range of a given function. The range of a real function, the range of a real function is the set of all real values taken by f of x at points in its domain. Okay, in order to find the range, the range of a real function, f of x, we follow these steps given below. Okay, we may use the following algorithm. We follow these steps. See this algorithm. Algorithm means a sequence, a series of steps. Step 1. First of all, we have to put y is equal to f of x. We have to assume that y is equal to f of x. Step 2. Solve the equation you have to solve this equation y is equal to f of x for x in terms of y. Then let x is equal to, from this equation we got here x is equal to pi of y. We got x value in terms of y like this. Okay. Now step 3. Find the values of y. Hereafter, we follow the steps where we follow to find domain of the function. Okay. Find the values of y for which the values of x obtained from x is equal to pi of y. From this equation, you have to find the values of y or real and in the domain of F. Now step 4, we got the values of Y. The set of values of Y. The set of values of Y obtained in step 3 is the range of F. So to find the range of a given function, you follow these 4 steps. You have to write first y is equal to f of x, and from this equation you had find the value of x in terms of y. After that we had find the values of y as we are finding the values of x. In the case of finding the domain of f, we follow the same steps here. Then you get y values. The set of y values is nothing but range of the given function. Okay, my children. So these are the points which are useful for this exercise. Okay, my children. Yes. Now the time is 10 past 44 minutes. All of you go through these notes. Go through these notes carefully and completely. Now you can leave the meeting, my children. Tomorrow we will start exercise sums, but in the meantime, read the given notes carefully and completely and try to understand the points. Okay. Just within one day, you can't understand. You have to read it thoroughly, read it again and again. Okay, my children? Right.